Okay. The recording.
Plus 157,4, okay, 5
Yeah.
times 5.01
Minus 36.87.
multiply by 5.01 angle of 86.57. The answer is 6,887, 337. Angle of 5.01. Yes.
Seems like after this exercise, I will know how to do all the problems.
So I know how to do them. The thing is, I don't know what's happening because I did when I use scale, it's a problem. So the other question says the developed power in terms of load angle and impedance angle and the maximum
All right.
current.
Okay. What is the load angle?
The load angle
Yeah. Delta. No.
is that one again? It's 5.01.
Yeah, but it's delta. And the impedance angle is beta. So that means you must use the long formula.
Sir?
That gives you a clue that you have to use the long formula.
A.
And
Yes, the whole formula, the big one.
Yeah. So that will be E over Z.
E cos beta minus V cos beta plus.
Exactly. Okay, so now we just stick it in there and calculate it.
Yes, it's the answer is 2.422 megawatt.
Per phase, no?
Yes, sir.
Okay.
And then it says, and the maximum current.
No. That answer had 2.422.
Yeah?
That answer of 2.422 is not per phase.
Okay.
It's not per phase. It's not per phase. It's I didn't say it's per
Okay.
phase. I said megawatt.
All right, so I and Max. You can sort of calculate it. So that will be 6,887.37 and 7.
Angle 86, 86.57
.6 minus 6
minus 6350 angle 0 over 5.01.
Yeah. Angle 86.6.
Yes, which is 1813.
1813.
13,712.
712.
Angle 44.25.
Okay. How about this leading net?
Yes, it's a leading power factor. And then it says, and the developed power in terms of power factor and load angle. So you use that smaller one.
Yes, EI equals.
E times into a current cause of load angle plus or minus power factor. Yeah.
So that will be 66887.37 times 157.5 cos of
5.01
plus 36.86
plus 36.87. Yeah, it's 2.422 megawatt.
It should be the same.
Yes. After it says also draw appropriate phasor diagrams. Yes.
This one you can draw. I didn't ask for scale, so first of all you're gonna do
just draw.
Yeah, you just draw them. That's the first one, and then for the maximum, it will be like that.
You just do that.
Yeah.
Okay.
All right, seems we're almost running out of time again. All right, you've still got 10 minutes, then you can reconnect again.
So you need to label it again. So the other one is 1.
Blah, blah, blah. I1, I2, and so on.
Okay,
Alpha
so it's
and beta and phi and phi, so on. Alpha mark is
so
for.
say okay, sharp. So the other question, 4.3, if the steam input to the turbine
Yeah.
is increased by 10%,
Yes.
yes, the induced EMF,
The induced EMF. Okay, speak again. Ona? She's muted. Ona, I can't hear you speaking.
okay, I'm saying it says if the steam input to the turbine
Yes.
is increased by 10%,
Mm.
which means is your developed power get increased by 10%. The
Yes.
induced EMF remaining constant.
Yeah.
Determine the new load current and the power factor.
Mhm.
Yes. So which means your P1 it's 100%, and then your P2, yeah. Then your answer is.
And then determine your
Yeah,
new
we'll
load.
give you answer. Your answer is 2.664.
Okay. Now you're going to stick it in
It's
that long formula and determine your new load.
megawatt. Sir?
Now you're going to stick it. What was the question? What is your new load?
So, sir, which means your angle 2, you can say it's equals to 1.1 multiplied by load angle 1.
You can check it
You
out.
can still, sir?
It should be.
Yes, do it. The angle we want to use it. Load angle 2 is equals to 1.1 multiplied by load angle 1, which is equals to 5.51.
Yeah.
It's 501. F there it's 01, yeah. Which it give you 5.51, yeah.
Yeah, and then you can check it by saying P2 is equal to E
Yeah.
over Z
Yes.
in the formula, and then you will get delta there, which will give you the same.
Yes, sir. And then it says elucidate by means of phasor diagrams what would happen to a single alternator if the load at the same power factor is increased.
Mm-hmm.
Yes.
So what's going to happen?
And I didn't say.
Single one. The single
Sir?
one is not connected to the internet, to the infinite bus.
Sir?
Yeah.
I don't hear you. What are you saying?
I'm saying it's not connected to the infinite bus. So now what's going to happen? What do you think is going to happen?
For what? For this question?
Yeah.
Let me see if the load at the same power factor is increased.
It means that will happen.
Sir, we can't see the page. Can you take it down? I can't see. Okay. It will double. Yeah. Yeah. That's what's going to happen.
Yeah. So you can just draw that to scale and say, all right, if that one is equal to that one, and then blah, blah, blah. Do the same thing.
Okay. Another one, 4.45. It say expound by means of a phasor diagram. What would happen to an alternator connected to an infinity bus if the steam admission to the machine is doubled? The excitation remains constant.
Yes. So if the steam, okay, that was the first one. Yeah?
Sir?
this is the condition. Huh?
It's
Now it says if the steam is doubled, what is going to happen?
yeah, the steam admission to the
Yeah,
machine is
so-
doubled, which means your developed power
Yeah, so that's going to
is
increase.
doubled.
Yeah.
So it's going to increase.
Yes.
So what's the problem? So which means for 4.3, we don't draw
No,
the
specific.
load.
Yeah, you just
Sir,
not the scale.
sir, I'm talking about 4.3.
Yeah.
We don't draw the phasor, the load and diagram for it.
Yeah, you do.
The one for 10% increase.
Yeah.
Oh, we only calculate.
Yeah.
Okay. So that was the problem. So I wanted to ask you, ne, from your load diagram,
Mm.
is there any way you can measure your power? Because I see other things you can measure them and get them, like current. You can confirm your current from your
Yeah.
load diagram. So what about power? How do we confirm it?
Normally the same thing. Let's say first of all you've got it in phase.
So the page, it's we can't see. Okay.
All right, let's say you've got current in phase. Now, remember, you draw a line perpendicular to your IZ.
Yes.
All right, so if E now becomes bigger, or it goes that way, but for the no, we want more power.
Yes.
Let's
Yes.
increase the angle to the same length, eh? Then it goes there. So now,
Oh, yes.
to that, past that point. So if that is 1 per unit power, then you measure that
Yes.
in terms of that
It's
distance,
a double.
and then you get the power.
So when we get there, it's you saying our power is one multiplied by ZS.
Yeah,
So you get maybe your scale when you measure. Maybe I use 1,000 or whatever. Maybe when I measure,
yeah.
I said
Okay,
maybe
let's say
by
that's
1
the
centimeter.
power. Let's say that's the
Let's
power.
give example. Say, let's do example. Maybe when you measure that line, you get 2.4, which means you're going to multiply that by 1,000.